Hello again, this is the Pencrest High School AP Physics C video series. This is vector 2b, Newton's laws in 3 dimensions. So we know that force is a vector, so it has a magnitude and a direction. If a series of force vectors is indicated in IJK notation, and we need a net force, all we have to do, because the IJK notation indicates the x, y, and z components, all we have to do is add the I terms, add the j terms, add the k terms, and these results, these sums, are the x, y, and z components of the net force. If we were adding force vectors in 2D, we would have to determine the components using sine and cosine functions. Once again, since IJK notation already has the vectors in component form, it's actually much easier. Right? Of course, you can still list the vector components in a vertical arrangement or vertical table with x, y, and z columns if you prefer. But the point is, adding the components of different force vectors in IJK notation is very easy. So we have a simple example here where we have an object that can slide over a frictionless surface. The surface is in an XY plane. One thing that's not indicated here is that we are looking at the object from above. So in other words, we don't have to consider the gravitational force because it is acting sort of into the table or into the plane of the XY plane where the object is moving. So we have two forces that are acting, and in each one of these question parts, A, B, and C, there's another, the second force is given in IJK notation. That's different from F1, which is given in the problem statement. And it wants you to list the acceleration of the chopping block or the object in unit vector notation for each of the following second forces. So when you look at A, you look at F1 and look at F2, it should be pretty obvious that when you add the x components, they cancel. When you add the y components, they cancel. So therefore, the object will not be accelerating because the net force in each case is 0. Question B, again, the method is just as easy. The y components do not cancel in this case. We would have to add them up. So we do get a net force in the y direction. And that 7 newtons in the j direction is effectively the net force. To go from net force to acceleration, of course, we just have to divide the net force components by the mass of the object, and so on. So the third one is similar, only the x components don't, cancel out. And we add those up and divide by the mass. The bottom line is, in IJK notation, finding the net force is really very easy. So that probably the shortest AP Physics C video of all time. But next up is velocity dependent forces, which is a new concept and a new idea. So until then, enjoy, and I'll see you soon.